Welcome back to another lecture from organic chemistry. In this lecture, I'm going to go through organic chemistry. In this lecture, I'm going to go through naming alkenes that they have more than one double bond. How do we name those alkenes? First, let's focus on how actually we get alkenes. So I have a compound that's made of 4 carbons and all bonds are saturated, and the name for it is going to be in butane. Okay, why butane? Because we have 4 carbons, and we want to say that it's saturated, so it will be butane. Okay, if there is a double bond, and double bond, I'm going to put it here. Now that I have a double bond, that means I remove 2 hydrogen from the system. Okay, and remember, originally we had CnH2n plus 2, so it used to be C4H2n plus 2. It will be 4 multiplied 2 plus 2, that's going to be 10. Okay, we're going to subtract 2 hydrogen from the system. So minus 2 hydrogen, and the formula for alkene, it will be CnH2n, and the 2 is gone. So that 2, we don't have it anymore. Okay, and then name for this formula, this compound is going to be this. You start from the double bond, you give it the smallest possible number, so it will be 1, and then you go 2, 3, 4. We have 4 carbons, and the double bond started from the first carbon. So you can say 1, and then you say bu. You want to say there is a double bond, you add en. Okay, so an is replaced by en to say that we have a double bond, and we add e at the end. So butene, or you can simply just say butene. Butene, and the formula for it is going to be C4H subtract 2, so that's going to be 8. Now, what will happen if I take another 2 hydrogen from the system, so minus 2 hydrogens. Okay, if you take 2 more hydrogen, now the formula is going to go down to CnH2n, but this time it will be minus 2. Okay, minus 2. And we have a triple bond, and that triple bond is made of 2 pi bonds technically, and 1 sigma bond. Because the first one is always sigma, and the second it will be pi. Okay, for alkene, we used to have 1 sigma and 1 pi. Now we have 2 pi's and 1 sigma. And for alkane, it's always going to be saturated, so 1 sigma. Okay, and the name for this compound is going to be this 1-bu. This time we're going to replace the an by yn to say or show that we have a triple bond. Okay, so it will be butane. Okay, do I need to write 1? Not really. So you can just simply say butane. And the formula, it will be C4. We subtracted 2 more hydrogens, so it will be 6. Okay. And so we have 3 hydrogens there, 2 hydrogen here, and 1 hydrogen is attached to that carbon. Okay, so total we have 6 of them. Okay, let's see. So we have alkene that has a double bond, and the double bond is sitting on the first carbon. So we said the way we're going to name it, we just simply say 1. Okay, why 1? Because we want to say that we have a double bond and sitting in the first carbon, 1, and then you say 1, 2, 3, 4. Okay, so I can call it 1-butene. Okay. Now, what will happen if we introduce 2 double bonds? Okay, and then in that case, the question is going to be, where are those 2 double bonds? Okay, the first double bond is between carbon number 1 and carbon number 2. So first number is going to be 1. And the second double bond, we can see it after reaching third carbon. So on 1 and 3, we have double bond. So we say dash, okay? Then how many carbons we have? We have 4 of them. So I'm going to say bu. Okay, I want to say 4 carbon. And then I will add A here, buta. Okay, and then I want to say I have 2 double bonds. In order to say the 2 double bond, I say di. Okay, di for 2 bonds, 2 double bonds. And then you want to say di-en. Okay, di-en. And then we add E at the end. So 1 and 3, butadiene. Okay, butadiene. Okay, how about this? Again, 1, 2, 3, 4. Yeah, we just named it 1, 3 butyl di in. Okay, let me change color for them. So I'm gonna go A here, and then I say di for 2, and then EN and E at the end again. Okay, how about this? Okay, next example, you need to figure the longest chain, the chain that is the longest, it has the highest number of carbon, and also start with, you know, like, or start with double bond, or it's including the double bonds, yeah, including the double bonds, both double bonds. So that's gonna be the longest chain. And now, like, from which side I need to label it? You should start from the left side. Why left side? Because that carbon double bond is going to get the smallest possible locator. 1, 2, 3, 4, 5. So we have 5 carbons. Okay, on the second and the third, we have methyl groups. So I'm going to say on the first, okay, and the third one, I have 2 methyl groups. So I say di, and then I say methyl, dimethyl. Okay, next, okay, where do I have those double bond? On the first and the third one. So I'm going to say 1 and 3. Okay, and then forgive me, like the double bond, the methyl was on the 2, the double bond, the methyl was on 2 and 3. So it should be 2 and 3, not 2, 1, 3. 2 and 3, dimethyl. So the carbon, the first methyl is on the second carbon. The third, the second methyl is going to be on the third carbon. Okay. This methyl is sitting on the second carbon, and that methyl is sitting on the third carbon. Okay, it's 2 and 3, dimethyl. And then where are the double bonds? First carbon and third one. So I'm going to say 1 and 3. And then I want to say I have 5 carbons. My chain, it has 5 carbons. So I go penta. Okay, penta. Okay, penta. Then I say di. To say that I have two double bonds. Diene. Okay, so this one will be 2 and 3 dimethyl, 1 and 3 pentadiene. Okay, another one. Okay, we're going to label it from here. 1, 2, 3, 4. Okay. You're going to label it in a way that you're crossing the double bonds and also giving them the smallest possible locator. So you're going to say on 1 and 3, I have double bonds. Then I say 1 and 3. This compound is made of 5 carbons, so it's cyclic, and you will say cyclo. Then you say penta. Okay, penta. So you add this A at the end, penta, and then you say I have 2 methyl. You say diene. So it will be 1, 3 cyclopentadiene, and that's going to be the correct name for it. Okay. Whenever we have more than one bond, like whenever we have more than one actually double bond, we might get, we might get E and Z structures or isomers. We need to mention them. Why? Because that's going to make it easier for audience to know how to draw the structure. Okay, even if you have one double bond, just one double bond, and there is a like a Z or E isomer there or cis or trans, you have to mention it because it's helpful to understand the structure of the molecule. Structure will determine whether the molecule is polar or non-polar. Okay, in this case, okay, we have says 1 chloro 2 and 4 heptadiene. First, let's figure out how to name it, and then we're gonna go through like putting E or Z for double bonds. These 4 structures are isomers. They are the same, okay? They are the same. I'm going to try to show you how to actually name the compound. Okay, we're going to start with this carbon. Why that carbon? Because if we started from here, double bond is going to get 2, and versus if I start from here, I get 1, 2, the double bond, it will have first locator with 3 instead of 2, so that's not gonna be correct. Okay, we're gonna start the labeling from the left side, and we get 3, 4, 5, 6, 7. So we have 7 carbons. Okay, next we have 2 double bonds. Okay, 2 double bonds. And also we have a chlorine. Okay, there is a chlorine, and that's a chlorine. Okay, how do I name this compound? Okay, first I'm going to say on the first carbon I have chloro. Next, okay, on the second and the fourth one I have double bonds. So 2 and 4, I go hepta, hepta, have 7 carbon, and then I say hepta, and then I say di, then I say En to say I have double bonds, and then I add E at the end. So 1 chloro, 2 and 4 heptadiene, that's going to be the name of the compound. Okay. Doesn't matter where those substituents are, whether they are in the same direction or opposite. Okay. You have to mention it because that's going to change the physical and chemical properties of the compound technically. And so you need to mention them. Okay. In this case, I have here 2 hydrogens. Okay, 2 hydrogen there. Okay, and I also have okay 2 hydrogen here. So okay, I can use I can use E and Z. It's possible also to mention trans, cis and trans, but prefer to go with E and Z. Okay, how do we use E and Z? If they are on the same side of the substituent or the same side, you go with Z. If they are across of each other, it will be E. Okay, this is going to be your first substituent. Okay, that's the first substituent. Where is the second substituent? The second substituent, it will be that carbon. Okay. Now the question is like, should I call this one E or Z? Okay. This substituent versus hydrogen is going to get higher priority. So this one, it will be number 1. Okay. And again, hydrogen versus this carbon will get the highest priority, the higher priority than hydrogen. So in this case, I have 2 substituents. They are the same side, and this is going to be technically Z. Okay, so I'm going to erase them. And this one, it will be Z. Okay. So the first bond, it has Z in a Z structure. Okay. Next one, I have a substituent that is here. Okay. Versus this substituent, the one I'm going to highlight, versus that substituent. So one substituent is here, and the second substituent cross of it. And we're talking about this bond, the second bond, and because the two substituents are across of each other, this one is going to give us E isomer. Okay, so I got E for the second one and Z for the first one. Let me erase that one to make it clear. Okay, so we got Z and E. Okay, now time to finish the naming. Okay, this is name of the compound. Okay, you want to say the first carbon, the first double bond, it has a Z structure. So you say parenthesis. On the second one, it has a Z structure. And the second double bond, which is started from 4th carbon, it has E structure. Okay, and that's going to be the full name of the compound. Okay, so from now we're going to just simply change these 2. Okay, we're going to change those 2. Okay, so you can say this one is the yellow double bond and that one is the orange double bond. Okay, very good. So let me copy paste that one. Go after next structure. Okay. So next structure, we have one substituent is here. One substituent is there. Okay, the next substituent is here. So their position and it will be cross of each other. Okay, and so this one, it will be E. So I'm going to say the first one, the second card, forgive me, the first double bond, it has E structure. And next, if you erase, okay, erase that, and focus on this double bond. That double bond, it has one substituent is here, and the second substituent is that one. They're on the same side, so this one, it will be Z. So you say this is going to be 4Z. And that's going to be the full name of the compound. Okay, as I said, if you have cis trans or E and Z, you have to mention it. Another one, okay. First substituent is here, the second substituent that attached to this double bond. Look at that double bond. Okay, first substituent is here, the second substituent is there. They're across of each other. This is going to be E. Okay, next double bond. This is the second double bond. The first substituent, it will be that one. Okay, and the second substituent is there. So that one also is going to be E. So in that case, you will say 2E, and the fourth also it has E structure. Okay, and I'm going to stop the lecture here. Thank you very much.